Well, thanks, and it's great to be here this morning among so many friends and tell you about some of the things going on at NASA. I was supposed to be done about 8 minutes ago, so I'll try to go through these kind of quick. But I wanted to give you a little bit of background on the new Office of the Chief Technologist within NASA and some of the things that we're trying to do, and some of the activities that we have underway with regard to commercial space, and some of the things that Rick was just talking about of how we want to work to create economic opportunities and really move NASA's focus beyond low Earth orbit and create commercial infrastructure, commercial capabilities, systems and services in low Earth orbit where NASA can be buying services instead of owning and operating systems. So OCT, the Office of the Chief Technologist, was established as part of the President's budget rollout for the FY11 budget in February of last year. And there are 6 main goals that the administrator gave Bobby Braun, who is the Chief Technologist, when this organization was stood up. And I won't read through all these. You can see them, and these are all on the website. But working with commercial industry, looking for partnerships, trying to look for commercialization opportunities are all key elements of what's in the charter for the Office of the Chief Technologist. And if you just go to the NASA homepage, www.nasa.gov/OCT, you can get charts that describe in detail. We just had an industry forum a couple of weeks ago, and there's a lot of information there. So many of these charts were taken from that to summarize. So if you want to learn more, that's a good place to go. And this chart summarizes the basic approach that we have within OCT for technology development, where we have 3 major activities of technology that we're looking at that are sort of aligned with different levels of technology maturity or the technology readiness level scale. We have early stage innovation, where we want to invest in hundreds or maybe thousands of ideas and see which ideas really have merit. So there will be all sorts of ideas coming from government, from industry, from academia, and we'll be assessing those activities. And for the ones that look really promising, we'll be investing in game-changing technologies to get the technology readiness level up so that they're basically ready for some sort of a space demonstration. And then we'll have cross-cutting capability demonstrations where we'll take those technologies and actually demonstrate them in space. And one of the aspects of this part of the program is we're looking for partnerships in the commercial sector, internal to NASA with some of the mission directorates, or with other international partners or other government agencies, so that we try to make sure we have some path for these technologies to go on. So one of the requirements for the capability demonstration missions is they have at least a 25% contribution from the partners. So we're sort of building in that partnership is a requirement, and we want to have a path for these technologies to go on. And in the President's FY11 budget request, the request level for the Office of the Chief Technologist is about $570 million. And the Innovative Partnerships Program, which I've been running, is being fully integrated into the Office of the Chief Technologist. And so one of the ways to think about it is all the things we've been doing in technology are being more than doubled in this request. And then for the plan in 2012, it's being more than doubled again. So in 2012 and out, the budget plan has over $1 billion a year for these kind of technology activities. And if you look at these 3 areas, it's roughly about a third in terms of the investment. So what are we going to be doing with these different kinds of technology investments? We're working to build disruptive and game-changing technologies. Looking at strategic opportunities to advance scientific discovery, human and robotic exploration, and new and innovative space technologies and mission capabilities. And commercial activities are a key component of that. And so there are a number of important technology demonstrations that are going to enable these kinds of activities. So we've been looking at what are some of the grand challenges that can shape where we want to make some of these investments that may be able to transform the way NASA does things in the future. And so these are just a few of those examples. fast and economical space transportation, enable in-space commercial marketable services. We're doing a lot of research into those areas right now. In fact, those two are sort of the product of some activity that we've been doing internal to NASA and working with industry to try to understand where some of the really high leverage points are, where NASA can help enable some commercial activities. And low-cost access to space is a clear enabler of many, many different things, and can help NASA, can help us do things much more effectively if we can get into space for a much lower cost. And that can also spur a lot of economic development in space. And the other is in-space services and in-space capabilities. So we're very, very interested in pursuing those things. And the technologies that we're pursuing can have an important impact across this whole range of grand challenges. And we're working very closely with the mission directorates within NASA as well, with the Aeronautics, with the exploration systems, with space operations, and also with science. And this particular example here is sort of illustrating the relationship that we're having with the Exploration Systems Mission Directorate, where they've got some defined missions that they want to pursue. They have technologies that they're investing in that will enable them to get on the path for those missions. And they have that, they don't want to take on things that are too high risk. They want to have high probability of success for their missions. What we're doing in OCT is developing in higher risk technologies that, if successful, might transform the way things are done. And so we're sort of the technology push activity, whereas the mission directorate technologies are more of a technology pull, where they've already got a direct linkage, they're in direct support of a particular mission, whereas we're investing in more high-risk technologies that may have broader application and may create opportunities for whole new ways of doing things. So as I mentioned, the Innovative Partnerships Program is rolling into the OCT and being integrated into this new program, and it really gives a very strong base for beginning the OCT. Of course, Centennial Challenges, and you heard from Andy Petro on Thursday night about the great success that we've had with that program and the 3 new challenges that we just announced a couple of weeks ago. And small business innovation research, small business technology transfer, and the resources for those will actually be increasing. It's a percentage of extramural R&D as defined by Congress. So as we transition from shuttle operations and we're putting more of the agency's budget into research and development, the SBR budget will actually be increasing. Our seed fund activity that we had for leveraged technology partnerships, and also another activity we had called the Innovative Technology Initiative, which was focused on funding innovative ideas internal to NASA centers, is becoming the Center Innovation Fund. Our fast and cruiser projects for using commercial services for parabolic aircraft and for suborbital reusable systems to test technologies and do science is moving into the Flight Opportunities Program. And our partnership activities, technology transfer and commercialization, moving into the new element within OCT, which I'm heading, called Partnerships, Innovation, and Commercial Space. And all of the center field offices that we have at the 10 field centers, they're being integrated into the Chief Technologist offices at the center. So each field center now has a Chief Technologist who will have responsibility over all of the Chief Technologist programs, including all of the IPP activities at the centers. And you can see some of the budget numbers here, and we're really aggressively moving forward with the planning. There have been some RFIs out, and we're hopeful that we'll be able to move out soon with those, pending what happens with the Congress. So this is the organization of the Chief Technologist, and you can see where some of the different elements from IPP are in the new organization. I'd talk a little bit now about what we mean when we talk about innovation and in partnerships. And part of what innovation is about is risk-taking and not being afraid to fail. And that's sort of a mantra of the new Office of the Chief Technologist, is we want to be doing high-risk things, and it's okay to fail because we learn from the failures, and we build on those into our successes, and we move forward, and we take the most successful things, and we move forward and advance those technologies. And also in innovation, it's not just about investing in new technologies, but it may be about taking existing technologies and looking for new ways to apply those, creating networks and partnerships and putting organizations together, really putting technology to work. And what we're looking for in partnerships are partners who have skin in the game. We're looking at adjacent markets where there may be similar technologies, leveraging similar capabilities. And I think in the macro sense, this is exactly what we're trying to spur in low Earth orbit, is the kind of commercial activities that NASA can use the services from, and they can also service a number of other different markets for other government agencies, internationally, commercial activities, and so on. So really, we're looking to try to match technology needs with technology capabilities. And entrepreneurship and innovation are a centerpiece of the administration strategy. There was a strategy for American innovation that the administration put out last September, and it talked about the importance of entrepreneurship, and the kind of things that we're trying to do in NASA are really right in line with this, and really trying to drive opportunities for space commerce and entrepreneurship with the investments we're making in the Office of the Chief Technologist. And just as one example, and I mentioned you heard from Andy Thursday, but the success we've had with Centennial Challenges has really helped to inspire a more government-wide interest in prizes, and there was actually a memo that went out from OMB to all agencies laying the framework for pursuing prizes on a government-wide basis. And so we're real proud of the success that we've had with Centennial Challenges. So what are some of the things that OCT can offer, and why should industry be interested in these things? Well, there's funding or leveraged resources that we can do through the range of activities in the 3 technology areas: early stage, game-changing, and cross-cutting. There's also technology and software that can be provided through licensing and other partnerships, test and demonstration facilities and capabilities. There's a tremendous wealth of infrastructure at the NASA field centers, and we can provide access through things like our flight demonstration program, and also a lot of expertise. People can access the NASA experts across the centers through partnerships, and through the program we can help put together partnerships and be sort of an advocate or a change agent for pursuing some of these things within the agency. And if you're looking for particular technologies, there are many, many technologies of interest, and what we want to do is make the awareness of these technologies out there in the community so that you can not have to reinvent the wheel, but look for other companies who may have been investing in these technologies through SBIR or other activities, and get different entrepreneurs connected so that they can form these sort of partnerships. And these are just a few of the websites where you can search out some of those partnerships. We have NASA Tech Briefs, which we publish every month, which has each month about 40 new NASA technologies that we put out there to about 250,000 technologists in every industrial sector across the country. And we have online databases. We have a RSS feed when there are new patented technologies that are available out there. And we've been working with the NASA Technology Transfer Center, and they've been producing a series of analyses of technologies in certain areas. And you can see here small spacecraft or navigation technologies or inflatable technologies. And these are all available online. And there's also CDs that have been produced where you can look at the whole inventory of NASA SBIR research for the last several years, or DoD research. It also includes things that have been patented lately from the U.S. Patent and Trademark Office. So these are all available as a resource to try to help make these connections and make sure that we're not reinventing technology over and over again, but taking advantage of what's already out there. Just a couple of examples that you may be aware of in the relationship to NASA and how licensing and partnerships have helped enable some of these things. With Ad Astra and Franklin Chang Diaz, of course, he was a NASA astronaut, did some research when he was at NASA, And then when he left to start Ad Astra, the technology for the Vasmir rocket that was developed at NASA was actually licensed to Ad Astra. And there were Space Act agreements and NASA experts who went to work with him and share their expertise and develop those capabilities, and there was access to NASA facilities and so on. In fact, I don't know if Andy mentioned this to you, Andy Petro, when he was here on Thursday, but he spent a couple years working with Franklin at Ad Astra. He was one of those NASA experts who went under the Space Act agreement. And the same kind of arrangement with Bigelow. You can see the picture here, their Genesis 1 inflatable spacecraft. They licensed inflatable technologies from NASA, and there were Space Act agreements put in place. NASA experts who went and worked with Bigelow in their facilities to develop the technologies and sort of share that expertise. And it has sort of come full circle for NASA because we've been able to actually fly experiments on these experimental platforms that Bigelow launched. We're also looking at opportunities of open innovation, and I think you're familiar with Centennial Challenges. Here's another thing we've been trying using a platform called innocentive.com, and we had challenges from JSC, from Langley, and from Glenn. You can just see a few statistics here, but I want to point out that through these kind of mechanisms, we can really open up the aperture on innovation. And we had thousands of people participating from around the world on trying to solve some of these problems. And so we're trying to, as one of the key charters for the Office of the Chief Technologist, is try to create a culture of innovation within the agency and try to get the culture to move to a mindset more of proudly found elsewhere in terms of technology and ideas that we can bring into NASA and help us be more effective, as opposed to not invented here. So we're trying to do experiments like this and demonstrate the value of things like open innovation to break down some of those barriers. Just another example of something that we have out right now is x.Hab Academic Innovation Challenge. That's the Exploration Habitat. So this is something that we put out to universities, and their proposals are due next month, but we'll select 3 universities, and then they'll compete head-to-head in developing these inflatable lofts for this habitat. They'll actually go down to JSC and have a head-to-head competition. So part of the thing that we're trying to do here is to get the competitive spirit between universities focused in the NASA lab as opposed to on the football field. I love college football, but I want to get that same kind of excitement and competitive spirit in things like this. So we'll have these 3 universities competing head-to-head to see who can develop the best inflatable loft, and then the winner of the competition will participate with JSC in field tests. And NASA has had a long history of partnering and trying to transfer our technologies for public good, way back to the very beginning of the agency and the Space Act. And we publish our results every year in Spinoff, and these things are available online. And if you have not seen NASA Home and City, I would urge you to check it out. It's really easy to find. You see the URL there on the bottom, just nasa.gov/city. And you can go here, and a home and a city will pop up, and then you can go into the home and click on the bathroom or the kitchen or the living room and see where space technology is benefiting you in your everyday life, and it really is ubiquitous. And likewise with the city, you can go to the grocery store, you can go to the sports arena, you can go to the marina, you can go to the fire station, you can go to the hospital and see where space technology is around you in everything that we do. So the idea here is to try to connect with the public and see that tangible connection of space technology. And not to say that these spin-offs are the reason that we explore, but they're an important byproduct and something that we try to maximize, and all of us really do benefit from these things. And I think you're all aware of the new National Space Policy that just came out, and I won't read through all of these things on here, but just to point out that commercial space and the opportunities for entrepreneurship and building commercial space capabilities and having the government buying services is a common theme throughout this new document, right in line with the plan that NASA is trying to pursue. And you may have seen this issue of technology innovation that we did a while back. I'm not sure if we have copies here, but if you don't have a copy and you'd like one, just let us know and we can get one. But we highlighted in this a lot of activities going on across the agency with regard to commercial space, and sort of underscores the three themes that I saw in terms of how the relationship is changing between NASA and industry in the emerging commercial space sector. And one is that the relationship is moving to one of partner rather than a customer and contractor role, where with partners there's shared risk, shared ideas. It's not just here's what I say to do, you do it, and it's I think with the COTS model, it's a real flagship of how that is transitioning. And with a lot of other partnerships using Space Act agreements and other things, we're seeing this as well. Another one is the government purchasing services instead of owning and operating hardware. And we're seeing that with commercial crew and with commercial cargo as well. And we're even seeing that on the space station, where there's a Sabatier reactor that's providing water on the space station that Hamilton Sunstrand paid for all the development, and NASA is just going to pay for the water when it's actually delivered on the space station. And we're also creating broader opportunities for innovation, trying to cast a broad net, make sure that we benefit from sources of innovation that NASA wouldn't normally be benefiting from in the traditional contracting mechanisms. So things like Centennial Challenges and the open innovation that I talked about. And all of these things that we're trying to do within NASA and moving in this new direction are consistent with what NACA, the predecessor to NASA, had done in the early days of aviation. NACA, of course, being the National Advisory Committee for Aeronautics. So I thought I'd share this to talk a little bit about what is commercial space, and when we say commercial space, what do we mean? And there isn't a single discrete definition, but I put together this construct that I think helps talk about what we mean when we talk about commercial space. And if you look at the bottom left, that's sort of the traditional government contracting mechanism, where it's a cost-plus contract, government is the only customer, and the government takes all the risk. So this is the way things have traditionally been done for the last 50 years of the space program. But what we want to do is move towards the upper right, and the example I give there is commercial communication satellites, where you can buy bandwidth by the yard, and the government is just one of many customers buying those services along with all sorts of other commercial customers, TV networks, and so on. And when you buy bandwidth, you buy it on a firm fixed price. And so that's a mature commercial space industry, and there are a lot of things that we can do from where we are now in the bottom left to get towards the upper right in terms of beginning to share the risks, moving towards firm fixed price contracts, things where the government can be an anchor tenant that can help spur adjacent markets and build capability and so on, to where we get to the point where government is just one of many customers. So there are different paths that can be taken to get from the lower left to the upper right. And I think the COTS CRS model is a great flagship for how this can work with NASA in beginning to move towards having shared risk, government as an anchor tenant, and then really moving towards that ultimate objective. But I think this framework can be helpful in seeing how some of the things we're doing may be moving along one of the two axes, but ultimately where we want to go is in the upper right. So a little bit about NACA and just some of the background and context for how the early days of NASA's predecessor organization can be sort of an analog for where we are now in terms of the commercial space capabilities. Well, and NACA was created in 1915, and President Taft, this was of course after the Wright brothers invented the airplane, and there's sort of an interesting story there too, just real quickly. The largest ever federal R&D program at the time was for Samuel Langley, who was the world-renowned expert on aircraft. So he had this huge government R&D project to develop an airplane. And he had demonstrations and brought all the experts together and wasn't successful. And he had a huge gathering and tried to test his new invention in the Potomac River, and it crashed miserably and almost killed the pilot. So here was the world-renowned expert, having huge government investment to try to succeed, ultimately failing in a very spectacular public way. And then these bicycle mechanics from Dayton invented the airplane. So I think that's a great testament for open innovation and how sometimes the great innovations come from the places you least expect them. And the sources that you would expect them to come from may not be successful. And in a sense, what we're trying to do with our open innovation and our prizes and so on is look for the Wright brothers of the 21st century. So the Wright brothers did invent the airplane. The US didn't really move out. There were some different issues. The Europeans were aggressively moving out and developing this new technology. They used prizes to really spur a lot of things. So President Taft saw what was going on in Europe and said, well, we're falling behind. We better figure something out. So he sent a panel over to the Augustine Commission of the 1910s to go over to Europe and determine what was going on. They came back and they recommended that we create an advisory committee for aeronautics. And so there was legislation that was introduced. Congress defeated it until World War I started. And the US was in a position where we were having to build European-designed airplanes to provide capabilities for our armed services in World War I. So that sort of created a sense of urgency, and then Congress said, well, maybe that's not such a bad idea. So they ended up passing the law that created NACA in 1915. And it started with 12 volunteers and $5,000. So very modest beginnings. But they had great success without a lot of money, but they brought together different agencies to work together on common problems and break down some of the barriers for this emerging industry, and really took an overall view of national priorities and focused on helping to build the industry. So they solved a lot of practical problems, again, with things that didn't require a lot of money. And I'll not read through all these just because I'm trying to get through here. But they were focused on building an industry, not a program. And that's the kind of things that we're trying to focus on with a lot of the commercial space activities now and the technology investments. Do things to help build capabilities that can have broad application, create services that NASA can use, but that can also be used in other areas. And like I said, looking for the Wright brothers of the 21st century. So some of the things we have coming up that you may be interested in participating in. We're having our Sea Race Conference, which is a partnership with the Air Force. It's going to be here at Ames in October. And what we're trying to do here is bring industry and government together, sort of open up the government capabilities and look for partnerships and make those things available to industry, and also try to facilitate partnerships among industry. And there are a lot of things that we've been doing related to trying to help advance low-cost, reliable access to space. We're looking at flight opportunities, buying services from these emerging suborbital providers through Cruiser and the Flight Opportunities Program. And speak of the devil, there's one of our prospects there, Dave. And the Commercial Responsive Access to Space Technology Exchange, as I mentioned. We're working on a commercial RLV technology roadmap in partnership with the Air Force and the FAA to try to identify where some of the real high leverage technologies are that would make a big difference to industry in terms of moving forward with some of these concepts, and then take that into account in some of our investment decisions and where we're investing government resources in R&D, and working on some launch studies as well. So in looking at what some of the space technology demonstrations might be, these are just some of the concepts that we may have in a few years from these technologies. So inflatable decelerators, solar power in space, aero capture technologies, optical communications, and so on. So these are critical things that, and one that's not shown here, but there's a lot of interest in, is propellant depots. And I have a lot of interest in propellant depots and think that can really be a transformational kind of thing for a space architecture. where it takes a lot of requirements off of a heavy lifter. If you can bring things up dry and don't have to bring them up fully tanked, creates a lot of flexibility in your architecture, opens it up to spurring a lot of competition from launch vehicles that could be delivering the propellant not only in the US but also internationally, so it makes it much easier for international partners to contribute in some of these big missions. And it also introduces reusability for your in-space systems, which is huge. And as great as Apollo was, the only thing we got back from that huge stack was the little command module. And to be really affordable and sustainable, we need to start thinking about reusability. And that also enables things like in-space resource utilization, which are, again, critical for long-term sustainability and affordability. So there's some very important near-term technology building blocks and demonstrations that can have a huge impact in the future overall architecture and create a lot of opportunity, not only for NASA and making the kind of activities that we want to pursue beyond low Earth orbit much more affordable and sustainable, but create opportunities for the things that commercial entrepreneurs want to do and help create those capabilities. So there are many ways that the kind of investments that we're trying to pursue are important. And I think there's recognition that the things that NASA is doing really are a critical component of the innovation engine in the country. We're trying to foster American industry. And back to the previous administration, when the vision was rolled out, I thought that Jack Marburger, who is President Bush's science advisor, the way he characterized the vision, I just loved the way he described it, and he sort of boiled it down to his essence. He said, the vision is ultimately about expanding the Earth's economic sphere of influence. And that's, I think, a great way to think about it. And I think it's as relevant today as it was a few years ago. And an integral part of our national strategy and in helping to create excitement and motivation for the next generation of explorers. And the kind of things that we're trying to do in partnerships, innovation, and commercial space are really supporting all of those activities. So we have, as I mentioned, offices at all 10 of the field centers. There are folks at all of the field centers working commercial space issues, working intellectual property and technology transfer issues, and trying to put together partnerships. But if you're interested in talking to any of the centers, the chief technologists are a great point of entry if you're not sure who to talk to. So, so if you have any questions or want to pursue something, these are great points of entry, and they can connect you with who you should be talking to pursue things further. So that was what I had for this morning, and I know we want to get a panel started. Be happy to take any quick questions, or maybe we could just do them in the panel. Yeah.
I'll keep this one very quick. Brad Blair, just the word disruptive technologies implies that you're going to put someone's rice bowl or congressional district jobs in someone's congressional district at risk. In the process of implementing or supporting or nurturing these new disruptive technologies, what is your plan and what are your tools for dealing with that and the political pushback that inevitably results, especially in the careers of some of your predecessors?
Well, yeah, anytime there's change, culture change, or it's difficult, and we're going through a difficult time right now with all of NASA's activities. You know, we knew we were going to have difficulty with the shuttle transition, and then with these other changes in constellation, that just exacerbates that. And change is difficult, but I think we need to keep our perspective on the longer term thing. The natural perspective in the political environment is fairly near term and thinking about immediate impacts and about the next election cycle. But we need to continue to emphasize the long-term strategy and the long-term benefits. And I think as folks have said, getting through this transition is challenging and difficult, but I think we need to keep reminding folks about what the benefits are and what the potential is going to be in the long term. And I think, you know, with disruptive innovation, disruptive technologies, I mean, if you go back to the automobile and and how it replaced horse and buggies. You know, there was a lot of resistance to the automobile from the horse and buggy industry. And you know, this isn't the first time this has been dealt with, but it's always difficult.
We'll have to save other questions for during the panel, which we'll have coming up soon. So thank you very much.